Welcome. I know it is asking a lot for you to come sit down for an hour, 2 hours after you've put in a full day of work, so we do appreciate it, and we're hoping that you'll find that the time was well worth it. Today we are focusing on the rock cycle. Okay, and I know that is a standard in middle school that is covered in the 6th grade, but it's also reviewed in the 8th grade because it's tested. So before we get started, I want to give you just this 5-question pre-test or pre-quiz. Just, and this would be more so for the students. This you probably know the answer to every. Or do you? There you go. So just take a couple minutes. You should have a pencil at your desk, and go through and just answer whatever pops in your head, and then we'll take it again after we go through the activity and just see if anything has changed. Now, you'll notice probably if you flip it over, it's the exact same set of questions on the back, but right now just kind of put it off to the side. If you were real students, I would collect it. And, so you could not go back and change those pre-test answers. But you can just push it off to the side, and then we'll go back before you leave here today, and I'll ask you to go back in and answer them again, and then I will collect it just, as evidence of student learning. Okay, so let's go ahead and get started, like I said, so we can get you out of here. Today you are earning 2 PD points for attending, but then there are 3 additional points that can be earned, and if you'll go back into my learning plan, you'll see that it's just for the implementation of this activity with your classes or a class, a collection of the data, and then just a reflection on how the lesson impacted the student learning. And get that to me. I don't recall the due date for that. It's sometime in October. So just go back. It is on my learning plan. I didn't look it up before I came up here. So just take a look, and I'll remind you before the deadline that, hey, I still need something from you, something real simple. Do not stress over it. Just give me some write-up of how what you did with it, what your student data looked like, and just a reflection. Would you do it again? Would you change something? And that's all the evidence I need. You can scan it. You can email it to me. Send it through the courier. Whatever works best for you. Okay? So that's PD points. Now we're going to go ahead and get started. Today we are going to take a journey through the rock cycle. So this is the standard that is covered with the activity. And how many of you use CPOMs? Okay, there's a lot of information there, but that's just it. There's a lot of information on there, so it becomes very overwhelming to try to go through. But I'm kind of jumping on the bandwagon with Tammy Ellis. They're really pushing, because the resources are vetted by teachers. They're created by teachers. They're vetted by teachers. It is, if you do have time to start pulling, and Jen and I, Jen Davis, just that. I don't know how many you do not look familiar. To me, she may know some of you, but if there's ever a time, hey, I need a lesson on, something, shoot me an email, and we'll see what we can do to try to help you out. Kind of a plug just for the Okaloosa Science Initiative. Because I know I was a teacher I was in the classroom 20 years. I know time is probably our biggest enemy because we do not have enough. So anytime we can help, let us know, and we can cruise through that CPOMs as well, trying to help you find activities. So just kind of remember that in the back of your mind. So the standard that we're going to look at today, we're going to identify the patterns within the rock cycle and relate them to surface events such as weathering and erosion, and subsurface events such as plate tectonics and mountain building. And this PowerPoint, you have a copy in your binders if you want to take notes on it. We'll also put it onto the Okaloosa Science website, that's part of the school district's website, so that you can go back and refer to it, and I will probably send it to you through email from the My Learning Plan roster, okay? Now, this is just kind of a motivation question that you could put up there in the beginning of this lesson, just to get kids thinking. Which direction do rocks follow in the rock cycle? So just maybe take some questions, maybe just have them think, maybe have them jot down what their thoughts are, because this kind of gives you some information on each of the rock types, but there are no arrows there, and we see flow charts. We usually have an arrow showing us which direction we travel. So just kind of a motivation. This is probably how I would start the lesson off, okay? Now, we're going to review the different rock types just real quick because the rock cycle will mean nothing to them if they have no clue what an igneous rock is or sedimentary or so on. So just the igneous rock type kind of gives a description of how they're formed by the cooling and solidifying of molten material. Of course, the kind of igneous rock that forms is going to depend on what was melted and how it cooled. And then we base them or classify them based on their mineral composition and their texture. This is just a diagram that shows the difference between the extrusive and the intrusive igneous rocks, where one on the outside, Well, Jen? There we go. The one on the outside, of course, it's going to cool quicker, and it's going to result in crystals that are much smaller, okay? Whereas the intrusive, where they form under the Earth's surface, the magma, it cools a whole lot slower, leading to rocks that have larger, coarser grains, okay? Sedimentary rocks is the second rock type. This is formed as the rocks are weathered, they're eroded, they're transported, deposited, and solidified to form sediment at the Earth's surface or even within the bodies of water. And they're often deposited in layers, as you can see the different layers in that rock there. Sometimes they're clumped together, just depends on what's there and how they're packed down. And this particular rock type is one that we frequently see fossils or can find fossils in. Okay? Just kind of a diagram showing how sedimentary rocks might form with the step one, the sedimentation, then it's compacted, okay, then compaction further takes place, and then the cementation where they pretty much just sticks them together like glue. And there we go. There we have our sedimentary rocks. And then the last rock type is the metamorphic. This is where existing rocks that are subjected to heat and pressure are going to change in their physical and or their chemical properties. So when rocks are heated by magma, can cause a metamorphic rock. They can form from tectonic plates when continents collide together, just that pressure that takes place there. Or they can also form deep under the Earth's surface where you have high temperatures and high pressure from the rock layers that are sitting on top of it. Okay, it's just kind of showing you've got extreme heat here, you've got extreme pressure from the layers on top. Now, the rock cycle has no beginning, it has no end. Okay, and I'm going through this pretty quick because we have an activity or a game that goes along with it that I would like for you to have time to go through. Okay, it's an ongoing cycle. It's an ongoing cycle in which an existing rock is going to be changed from one rock type to another, and it's driven by subsurface events such as tectonic plate moving. As I mentioned, the continents colliding. They can be driven by surface processes such as weathering, erosion, and the depositing of the sediment. Okay, and this is just a short 2-minute video that will show a little bit about just the rock cycle. Let's see.
The rock cycle is a sequence of events that describes the possible fates of a rock as it is transformed from one type of rock to another. The fate of a rock is determined by its location. Let's follow one pathway a rock may take through the rock cycle. Our rock begins as molten rock material, or magma, deep inside Earth's crust. The magma erupts through a volcanic vent and flows down the cone in a river of lava. The lava cools and new igneous rock is formed. Because the rock is exposed at Earth's surface, it is vulnerable to weathering and erosion. Agents such as wind, water, and gravity break the igneous rock into small pieces called sediments. These are washed into the river and carried away. The river slows down as it empties into a lake. The water can no longer carry the weight of the sediments, and gravity pulls them to the lake bottom. Layer after layer of sediments are deposited in this way. The weight of the top layers pushes down on lower layers, compacting them. Even though they are compacted, space remains between the sediments. Over time, minerals form in these spaces. These minerals act like a glue and cement the grains together. The rock material that began as igneous rock has been transformed into sedimentary rock. The rock is buried deeply beneath Earth's surface. There are many forces acting on the rock. The rock is pushed, pulled, and squeezed by tectonic forces and the weight of the overlying layers. These forces, combined with the intense heat deep inside Earth, bend and change the rock, giving it different properties. The rock is now metamorphic rock. Observe how the forces acting on the rock have aligned the grains, creating banding patterns. Over time, the metamorphic rock may be pushed deeper into Earth's interior, where it melts and once again becomes magma. This is only one possible pathway through the rock cycle. Given the right conditions, any rock can be transformed into any other kind of rock through the dynamic processes of the rock cycle.
Did it come back? Okay. Did it? Okay. Nope. Okay. Can I move? Now, these are just some processes that impact the rock cycle. And what I try to do here is just kind of highlight the terms that are listed in that standard, so that, hey, I've covered it right here. This is your evidence of, yes, I'm touching on those key words pertaining to the rock cycle. Okay, the rocks are pushed up by tectonic forces. They're eroded by the wind and the rain. These eroded rocks then travel by wind or in moving water until they're deposited, basically setting up the layers. Okay, and then additional eroded rocks may bury these layers until heat and pressure comes in and changes the underlying layers to what we call metamorphic rock. So the more eroded rocks press the layers into eventually sedimentary rocks. Okay, now the rocks can also sink down into the lower layers of the earth by plate tectonic processes. These buried rocks can melt, they can recrystallize into igneous rocks, and basically the metamorphic, the sedimentary, and the igneous rocks can then be pushed up by the tectonic forces where the rock cycle starts over again. So it's just a continuous cycle going in all sorts of directions. Okay, now this is just kind of a diagram showing the earth, the under the earth's surface, the top, the surface where the mantle, the crust, the surface of the earth, they're thought of basically as a giant recycling machine, and rocks, something that we need to try to stress, they're neither created nor destroyed. They're just redistributed. They're transformed into another rock type or a different type of the same rock type. So a sedimentary can be transformed into a different sedimentary rock. Okay, now the rock cycle does not go in just one direction, and that's something, sometimes that is a misconception. Students, you see the diagram where the circles, but if you find a true diagram of the rock cycle, it shows that those arrows, metamorphic can change into an igneous rock, but it can also change into sediment, which then forms a sedimentary rock. So this is just something just very simple, but just something that they can see. The igneous rock can change into sedimentary or metamorphic. Sedimentary can change into metamorphic or igneous, and the metamorphic rock can change into igneous or sedimentary. So they have no preference. Okay, it just depends on the atmospheric or the environmental conditions that they are exposed to. Okay, now this is something I want to show you. It's just an interactive, has several different activities. Some you'll use, some you will not, because they're not necessarily something that that you need to cover. But this particular, it gives you an introduction. So it talks about the different rock types. And you may want to play around with it. It goes into the types of rocks where it gives a description of each type. Okay? But then it goes into even more detail or more rock names that I know they are not required to know. So just, you may want to play around with this. What rocks change, this will give a description of heat and pressure. Okay, and if you want to start here, you can see how a rock is altered when it's subjected to heat and pressure under the Earth's surface. So it just gives a little animation. And it also gives a written description on here as well. Okay, you can replay it or you can move on to the next, and it will show you then how melting or cooling plays a role. Okay, its impact. And then it also shows the processes of weathering and erosion, or compacting and cementing. Once again, with the written descriptions of each off to the left of the illustration. Now, transform the rock. This is something, even though they do not have to know specific rock names, just the rock types, it'll give you a description. The conglomerate has disappeared. What can turn pebbles and sand or sediment into a conglomerate or a sedimentary rock? So you've got your sediment, and of those processes listed there, you know, which process is going to help turn those pebbles and that sand into a conglomerate rock. Okay, so they can drag and drop, and it tells them if they're correct. Okay, the marble is gone. What process can turn limestone, which is a sedimentary rock, into marble, which is a metamorphic rock? Let's just say, I'm going to put the wrong one on there so you can see what, and it will tell them it's incorrect, and then it gives them the correct answer. Okay, so you can do that all the way through. I'm not sure how many. I think there may be 7 or 8 different descriptions, and they basically fill in the blank. Okay, you can also go to the rock cycle diagram here. And it just answered the question. You know, when rocks are affected by weathering and erosion, they change into which of the following? Okay, and it will tell you if you're correct or incorrect, and if it's incorrect, it will give you the correct answer. So when sediment is compacted and cemented, it changes into which of the following? Let's just choose an incorrect answer. Okay, it'll say, sorry, that's incorrect, and then it gives you that correct answer. So you just go through there. And then it also gives you a test your skills. So you have to type in your name. It doesn't go anywhere, but and then it will just give you some multiple choice questions that you can go through. You know, so just play with this. We won't go through all of them, but it'll give you a question and then 4 choices. And then at the end, it will tell you how many answers it will not give you the correct answer as you're going through, but it will give you how many you got and go over those that you answered incorrectly. So it's just kind of a good interactive if, you know, you can get computers into your classroom. I know sometimes, especially during testing season, that's never. Are we back up? Yeah. Now, the last 3 slides are just some maps. Jen, do you want to talk about them? Because you've probably looked at them a little more closely than I have. And this is just something, although it doesn't really deal with the rock cycle, it could be something that you could use in another study.
My microphone on. Okay, so basically I just tried to get some resources together to make this a little more Florida specific, because I know relating it back to, you know, here specifically is a good idea. In your packet you have a little half sheet, or it's a third of a sheet, that has a couple of websites on it. I did pull these maps from one of those websites. There's a bunch of Florida specific information, and a lot of it, even Miss Linda in a minute will talk about, it's really specific, but it can give you a general idea to show to your students. So this one is the rock types and when they were formed throughout Florida. And they don't need to go through and know, like, what does the tertiary rock type mean. But it does give you a nice representation. If you look at Okaloosa, there's not that many different sediment types here. Versus a little bit different down here, and so you can look at it more in depth, but it's kind of cool just to show as a representation of what's going on in Florida. This one's kind of cool. This is the what do they call this map? The terraces map. So it's showing you basically elevation. And you can't see from here, but it's like 1 to 36 feet is the coastal area. And then it goes up in increments. So it just shows you, and I think it's the dark red is like 500 feet. So it's
The highest point in Okaloosa County is like 367.
367 feet in Okaloosa County. So this is actually just kind of a nice representation of how little elevation there is. There are some hills, and I've hiked up, I bet you probably have seen some of the hills too, going down the ravines. But it just shows you that, you know, along the coastline, yada, 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 you can kind of see that. This one actually, this next one's the coolest one, in my opinion. This is the sinkhole type. And it shows you the different types of sinkholes. So this is the limestone thickness. And the yellow parts are like, I think it's 1 foot to 15. It's really, it doesn't, I can't read it, but it shows you in here if you look at it online. So you can see that there are different levels of the limestone. We're in a pretty good area, fear not, but you can actually see where you would be more likely to have sinkholes. And then if you wanted to go into a little more depth about what a sinkhole is and why we have them here, relate it back to the hydrology. There is a hydrological map as well, which shows you the cycle here in Florida, which is really cool. There's a ton of resources. So those websites, if there's anything specific you're looking for and you don't have the time to look for it, let us know. Again, Lisa and I can do the legwork for you, but I just wanted to give you a little bit more information so you can relate it Florida specific if you wanted to.
Okay, so that finishes up the PowerPoint. And I'll send it to you. That way you'll have it. You can modify it, add to it, change it, it, whatever you feel. Sorry. You need to do with it. So next we're going to just kind of go through. This is a game that I pulled off of CPOMs and modified it just a little bit. Found another game very similar to it, just online, just in looking around. So it's in your packet, but I've also made some extra copies that you can write on, so that way you can take that clean copy, just keep it in your binder and use it, if you see fit. So it's called Journey Through the Rock Cycle. So if you'll look back behind you, you'll notice that we have 6 different stations. Okay, and each station is a different location. We have a mountain, we have an ocean, a river, a volcano, the Earth's interior, and soil. Okay, so what's going to happen is you'll give your students one of the rock cycle activity sheets. No, you only need one. And what you would do is you would go through and number your students off. Okay, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, so that you do not have them all, starting at the same location. So I'll do the same, for you. And basically what you do is once you go to the location or the station that you have been assigned, you fill out number 1. I began my adventure at the river as a sedimentary rock. And you'll notice on your station cards that it tells you the location, but it also tells you the beginning rock at that location. Okay, so we will all start with a different rock type. Okay, and then what you do from there, say you are at station 4 at the river. I'm a sedimentary rock. So you're going to roll. There is a cube at each station. Okay, so basically you just roll the dice. That was pretty sad. Okay, but roll the dice, and then it will tell you what you do. Okay, sediments form, you go to soil. Okay, so the process is sedimentation. So you're just going to fill out the activity sheet at each station. So it's sending me now, I am a sedimentary rock, and I am going to soil. So I'll walk over here to station 1, which is where the soil is. I fill in where I am, what I am. I roll the cube again, and it will tell me pressure occurs. Go to the Earth's interior. The process is pressure. So then I am a rock traveling over here to the Earth's interior. So I'm right here. So you get the idea? So you do that through 12 steps. Okay, through 12 steps. And once you have finished, then I would send the students back, and give them the second sheet. This is the data and analysis sheet. And I'll give you one of these as well so you can leave the one in your binder unmarked. Once they have their activity sheet, and this is just kind of where they're jotting down their notes, then they go back to their seat and they put it in a much cleaner, neater form, okay? And this is what I would take up for a grade. So they basically, it just will tell them, step 1, you started at what station name, you were what rock type, what process occurred, okay, pressure, and your ending rock type. So when it sent you over there to the soil, what was your ending rock type, okay? So you go through and you transfer it over here to this particular format. And then the analysis questions are on the back. And it just kind of has them thinking, why is there no beginning or end of the rock cycle? Okay, what natural events aid the rock cycle? So what natural events occurred that caused these rocks to change from one form to another? How does temperature and or heat affect the rock cycle? Does every rock have the same path through the rock cycle? Find someone who started, so this kind of has them going back to where they started. All the number ones. Go find another student that, okay, you started out as number 1, but what path did you take? So that they can see, even though they started at the same location, they did not take the same path through their rock cycle. Okay, and then basically, this is just kind of an extension, and I threw it on there. You could use it, you could discard it, but take what you learned about the rock cycle and illustrate or write a comparison to the water cycle. So it's kind of a higher end question, that would have them comparing, to the processes in the water cycle, or how it might be similar in terms of processes, or just the way there's no starting and stopping point. So I'm going to ask you to get up and just we don't have to go through all 12 steps. Okay, but I'll number you off, and we'll go through 2 or 3 just so you can kind of get the idea of how to fill out the form. And I will put one of these at your desk as you're moving around. And this is what, like I said, this is what I would have the students transfer their information to, just because it's a neater, easier to read, and then just their analysis questions. And also, they can use their evidence from the data that they collected to justify their answers in some of these. So it kind of gives it that complex annotation that they so stress for us to use. So we'll just go 1, 2, 3, 4. Okay, so go, and it's real quick. Fill it out real quick. And then this is would be an individual assignment, because as you see, not every rock follows the same path. So this could be something that, it may take the full class period to go through the 12 steps. This could be the homework, or, it would probably take more than one class period to complete the whole lesson with the game and the assessment. But I like the idea of maybe printing the rock cycle and putting at each station, just kind of as a heads up, hey, just something they can go back and just get some clues from as they are filling out their activity sheet.
Can you talk about the rock parentheses modification?
You could also because some, based on the process that you were exposed to, you could become magma or sediment, and you might want to just put the word rock in parentheses on the activity sheet, because it could be confusing to some students. And like I said, these will all be on the website. I can send them to you as well. They're all in Word documents, so you could go in and modify to fit whatever you need. And then share those modifications with us, so we may want to go in and change it to ours as well. Mm-hmm. Modified into a board game. Right. And so I'm sure it could. Right. And I had even thought too, even though they would be individual rocks, you could put them in groups to do the analysis questions, just so they would have some different experiences that they could share, which would help in answering some of those questions. But yeah, I would think a board game would be cool. Right.
Yeah, it might just be like how you move through, or way
Mm-hmm.
a group has a rock cycle diagram, and they can roll
Right. And there's probably one out there somewhere online. I'll have to look and see if I can find it. Yeah, there you go. Teachers pay teachers. That's make it up and yes. Yeah, Rockopoly.
Do it as like have them write the rules as an extra credit, 3 points extra credit for a quiz or something.
Yep.
Have them write the rules for it, and then you can next summer you could make it.
I had a couple make volcano games last year that were awesome.
Right, or at least it's a start, and then you could go in and exactly and modify to. Yeah, I like that. Okay, so and we're not going to have you go ahead and you get the gist of what the activity is about. And like I said, feel free to make changes to make it work for you. Okay, that's why we've put everything in Word documents so that it makes that process a little bit easier. Okay, now I am finished with my part, but I'm going to turn it over now to Dr. Linda Johnson. She's with the Yellow River Soil and Water Conservation. And she just has some good information. Really it's going to be more of a question and answer. She's just here to answer any questions you may have. But she also has brought some goodies that you will have the opportunity to go through and take out with you.
But this just meshes well with what we went through. It's basically the same thing. This is the way I learned it. And I made it big enough that you can make little notes on it. And the same with this. I wrote it out for you so that you could make notes on it. I'm used to note-taking. So basically what I did was I divided it up into the elements, which were the sediment and the sedimentary rock and the igneous rock, the magma and the metamorphic rock, and then the processes, weathering, lithification, metamorphism, melting, cooling, or crystallization, each one of those, and went around through it. And as you're going around the rock cycle, you can see that you can go across just like the other one. You can make a sedimentary rock and then have it weathered again and make a sedimentary rock again. You can do it. Could get caught in this loop where it doesn't go anywhere. It just keeps making more sedimentary rocks. And then it can also come down and be subjected to pressure and temperature and make an igneous rock, or metamorphic rock. The difference between metamorphic and igneous is the fact that it never really melts. Igneous rocks are the only ones that come out of melted rock, whereas metamorphic rock can go very close but not completely melt, and then they change, they transform that way. And when we get into processes, we can go. And then, of course, it can melt and become the magma and then cool down with the igneous rocks. So you've got it here in your little structural elements. And so I just went through it quickly and said, okay, the types of igneous rocks or sedimentary rocks are clastic, chemical, organic. Organics, of course, being fossils. Chemicals, what forms it together. And, of course, clastic is just the cemented ones that are there. And then, of course, metamorphic rocks are categorized by two forms: the texture, whether or not it's foliated or non-foliated. In other words, whether it has stratas or it's just one big glump. Think of quartzite. And then, of course, the name comes from what the parent rock was. And so a lot of times we have, I'll show you, we'll have muscovite garnet schist, which is very foliated. It has garnets that have grown. That's the easiest way to find particularly metamorphic rocks. You find a garnet, you know it's a metamorphic rock, and it falls apart. And then, of course, the molten magma. And then igneous rocks, we have the extrusive and the intrusive. Extrusive being lava, scoria, pumice, obsidian, the glassy ones. Very few large crystals at all. If they are any crystals at all, it'd be olivine, maybe in a little vent hole, or a little like when it's frothy and it has a chance to grow a little bit, but not very much. And then intrusive, of course, is deep down low. And so as it cools, it has time for the crystals to develop. The last one, of course, that filters out is quartz. And so we have different ones. The plutons, any kind of large areas. And then a stalk, you think of that part that came up from the volcano, the stalk. Bathyllus, that's another large. Bathyllith, yes, yes. And then, of course, the other ones, there's dikes that come up. When we saw the picture of, they had it coming up out of the magma, and it crossed the layers of rock, that's a dike. And then, of course, it could fill in between the two, that's a sill. And so those are the different kinds. And then, of course, the weathering, we have chemical and mechanical. Chemical, when your air, when CO2 mixes with water, makes carbonic acid, or even sulfuric acid if it's sulfur, particularly as it comes out of the volcano, makes kind of that, and that can change. Not only can it weather away, particularly those calcium-rich rocks, but it can also change the rock into a different composition. And then, of course, the mechanical, the wind, roots, water, frost, all of that breaks it down. And temperature, yeah. And then, of course, it's eroded, broken down, eroded, transported, which is another method. Sediments, and they collect together, and then they compact, and they cement together. So we have compaction under lithification, cementation, and even crystallization. There are some different crystals that are primarily sedimentary crystals. There's a strontium oxide. Can't even remember the name at the moment. Anyway, it forms in riverbeds, in little holes. And so different kinds of crystals, more than just like gypsum and things like that, can also form out of the water. Don't need to be magma or temperature like that. They will form salt crystals. That's the ones you usually think of. And then, of course, metamorphism, where, and I gave you the definition, they have transformation of pre-existing rock into texturally or mineralogically distinct new rock as a result of high temperature, high pressure. Sometimes it could be not just high temperature, but or it could be just high pressure, or it could be high pressure, not high temperature. Low pressure, high or low temperature, high pressure. The subduction zones. It's not real deep, so it's not going to be. But a whole different group of rocks will come from that. And then I gave you 3 different kinds. Contact. When we saw the magma coming up and forming a bathyllith in an area, every place it contacted. Remember that one point it said it was in limestone, and so it metamorphosed the limestone into marble. That's a contact metamorphism. And sometimes you'll actually see that. You'll have a granite dome area that's starting to erode where it's come to the surface through uplifting. And you'll see the little area along it that's marble. It's kind of cool to find those little contact points. And then regional, that's what we usually think, that big mass of magma that's cooling in the bathyllith will have time for all those crystals to develop. And then in a large scale, that'll be a regional one. And then hydrothermal, along those areas that are hot spots. And you think of where Yellowstone is with the mud things. It forms chemicals that are, different crystals from what's normally there because of the hydrology and the heat and the water. And then we're back to melting and then cooling and crystallization. So I just gave them to you, and we can go through them, but I thought the best way to do it is to pull out some rocks and go through the rocks.
Walkway there.
Yes.
It should be open.
These are
Oh, she's doing
these are
great.
ammonites.
There is a place up in central Indiana where you can go, and they've got the little, what do they call
These
it?
are crinoid stems.
That's what they have got. 'em
Here,
just
take you some
laying.
crin-
Is what they have. Well, they're smaller than this, but they've got them just laying everywhere.
Yeah, and crinoid stems came up, and then they looked like sea flowers. You know, they had a long thing and came up, and these are the stem parts. And so I brought these, and I brought
So pretty.
baggies, so you can mark them and take them home. A lot of these, yeah, take them for your class. You notice, usually you think of cementing as being, if we had some vinegar, we could see it bubble,
I love
as
doing
the
that.
calcium carbonate. But this one is cemented with quartz.
So it wouldn't. Yeah.
But you can see the fossils still in it. So it's not a metamorphic rock.
It's like a giant sand tree.
Yeah, you can see the rings. This is an ammonite. I brought, if you want to, if you're very, very curious.
Oh my gosh.
Here's some more. Here's some coal.
Big coal, not just
West
those
Virginia
itty
coal.
bitty.
Big coal.
This is totally like.
Here's
deep
some.
heaven.
These are really cool, and I want to say they're in Mississippi or something. These are,
Ammonite.
yeah. These are mud.
what?
It's a
Ammonite.
like think a nautilus.
Nautilus.
Like a nautilus.
Nautilus. That's one thing. I mean, this is a sea creature.
Yes, it's a sea creature. It's like a nautilus, but it.
Ammonite.
An ammonite.
Ammonite.
Everywhere.
Nautilus.
Right, these are all sedimentary, and I brought fossils too. These are crinoid stems from either Tennessee or Kentucky. I can't remember. But see, here's fossils. Here's like a fossil hash, but the matrix, the cement is quartz. See how heavy it is?
That's what it looks like.